Okay, guys, I'm going to set up the Salinization Lab experiment for you. It's a little awkward with the camera being there and my monitor's over there and my experiment is over here and here, but bear with me. We'll just laugh together, okay? At any rate, you should be able to write a formal description of what I'm doing here to set up this experiment. So scientific reports are very formal. They use a completely impersonal voice. Maybe you've had English teachers talk about your voice in your writing. For science writing, there is a very specific voice. It's very informal. And I'm going to talk more about that later, but basically it means that you're not here. I'm not here. This experiment is happening, and we're just describing how it's happening. You don't say, for example, first I did this. No, you don't say that. Instead, you would say, first this was done. So just think about that. It's a different way of writing. It's a little challenging, but I think you'll figure it out. So I've already set up some of my Petri dishes. I'm going to demonstrate how I set them up because these ones were the same, just different concentrations of salt. So first of all, I have 11 Petri dishes set up with a paper towel folded up inside here. The paper towel really just serves to keep the mung beans from rolling around. If you just put them in a Petri dish and they roll all around, and that's not so good for their growth. So we put a paper towel in there. I have already set up several Petri dishes. Maybe you can see them here, maybe you can't. There they are. Starting with 0%, which is just fresh tap water. All of these solutions were made yesterday. I filled up a jug of tap water, and then I measured different amounts of salt into each of them. The water has sat up overnight, which means all of this water, it doesn't matter which of these flasks it's in, it's all at room temperature now. And so the percentages that I'm using are 0, 1/2, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5. I'm using 11 different percentages, starting with 0%, increasing by 0.5% each time. So to set up one of these dishes, I take my solution. This one is the 3.5% salt. So this would, if I tasted this, this would be equally salty to the ocean. Of course, the ocean water would have a few other things in it that this doesn't have. This is just regular table salt in tap water. And I'm going to measure out 15 milliliters, which is exactly what I did in the previous Petri dishes. I've measured out 15 milliliters each time. I'm going to pour it into this Petri dish. Hopefully I don't spill any. And then I'm just going to kind of tap the paper towel down in there to get it completely soaking wet. Then I'm going to take 10 mung beans, 4, 6, 7, 8, 9, 10, and I'm going to spread them out across the Petri dish relatively randomly. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's good. Then I'm going to cover it. I'm going to grab a piece of tape, double check my percentage, and I'm going to put this little label on there, which, you know, that's not real important to describe. It's very important to do. The only thing to consider is that I'm putting each label in the same place on every Petri dish. So it is going to block off a little bit of the light, which is okay as long as I treat every Petri dish equally, blocking off the same amount of light from each one. I go on to 4%. It's a little bit more than my 15 mils, so I'm going to splash some back and add some more. That's better. A new Petri dish. pour it in, tap down the paper towel. Oh wow, I actually grabbed 10 mung beans that time. Spread them out relatively evenly, but randomly. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I'm doing 10 partly because it just seems like, you know, when we have bigger numbers in a scientific experiment, then your results are more reliable. You can count on them. It's not like, oh, I happen to choose a super freaky seed that grew extra well in this percentage, and I had some kind of lame seed in another percentage. If I only did one seed in each, I wouldn't know if it was just the genetics of the seed. But doing 10 seeds, I can probably make a reasonable conclusion, if there are any differences in their growth, that it didn't have to do with the genetics of the seed. I'm up to 4.5% now. Same story. I just repeat this over and over again. And that looks like 10. So the next step is I will roll this cart down to Ms. Sneerly's room. 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'll put it in the greenhouse in there where it will get light. Somewhat indirect light, but again, all of these dishes are going to be exposed to the same light conditions, right? So if it was direct or indirect, I guess it's important to make a note of that, but the important thing is that all of them get the same treatment, except the independent variable here, the one thing I'm altering is the percent of salt. I'm not changing the amount, but I'm changing the percent. So I'm giving every one of these dishes 15 milliliters of salt solution in those different percentages, 0 to 5%, counting by halves. And what I'll do, like in 3 days or so, if, like when we come back from the weekend, if the amount of liquid in the Petri dishes seems to be low, then I'll add some. 8. And if I add liquid to any one, of course, that also means I need to add the same amount of liquid to every one to keep it a fair experiment, to control that variable of how often they were watered. So I don't know if I'm going to need to water them yet or not. We will make that decision as we see the water level changing. Okay, so there's my 11 dishes, different salt solutions, same amount of solution, same temperature of solution, same amount of light, same number of seeds, same type of seeds, lots of controlled variables. We're going to let them grow for the same number of days. And then at the very end, the most important thing is we will make a comparison of how well they grew. And we're going to have to make a decision about how we're going to measure that growth. I think we'll save that for another day. There's some different options of what we could do to measure their growth. Sometimes we just make a visual comparison and it's pretty clear, oh, that one grew well and that one did not. But we really want to try to come up with a good definition of what it means to grow well. What does that mean? Does it mean that they're greener? Does it mean that their roots are longer? Does it mean that they weigh more? Something we need to discuss. So that's what I have for you there. All right, have a good one.